Hello everyone, myself Joel K. Moni, along with my friends Johan Sabu, Hebben Kurian, Jeevan Tieldo, and Harinarayanan KS of S3 Mechanical of Muthoot Institute of Science and Technology are presenting on our topic classifications of cast iron as a part of our metallurgy and material science assignment. So, the general question that arises in our mind before going into the classifications of cast iron is what actually is cast iron? So, cast iron is a term that is used to describe a family of metal alloys whose primary alloying element is iron. Because of its name, some people tend to think that cast iron basically is 100% iron. This is simply not true. In fact, carbon steel have higher amount of iron element in them than cast irons does. To consider a cast iron, a predominantly iron alloy must at least have 2% of carbon in it. So I hope you all have got a general idea on what cast irons are. Now going into the classifications of cast iron. So since we have a general idea on what cast irons are, now let us discuss on the second topic, that is the classifications of cast iron. Cast irons are generally classified based on the metallurgical structure and the appearances. There are four factors that control the structure and the appearance of a particular cast iron. The first factor being the carbon content. This is the most important factor among the four. Carbon is present either as a combined carbon in the form of Fe3C or as a free carbon in the form of a graphite. Carbon in cast irons are significantly influenced by other factors also. When alloying elements are present, alloy carbides are also formed in the alloy cast iron. Free carbon can exist as flakes or as irregular shaped globules, also known as rosettae, or as round nodules. Their size and distributions can also vary. Now, the second factor being the presence of other elements. Other elements may be also present in the cast iron as impurities or as alloying elements. Some of the elements stabilize carbide and keep the carbon in the combined form, while others have a graphitizing effect and promote the presence of graphite. Some of them combine with carbon and form their own carbides. And the third factor, the cooling rate during and after the solidification process. So higher cooling rate generally helps the formation of carbides, while the slower cooling rates helps in the carbon to be in the free form. Now the fourth and the final factor being the heat treatments. Heat treatments helps either in the formation of carbide or in the decomposition of cementite into free carbon. When carbon gets decomposed into graphite, heat treatments cause change in the shape, the size and the distribution of graphite particles. Depending upon the nature, shape, size and the distribution of carbon, the presence of other elements as well, the cast irons can be classified into grey cast iron, ductile cast iron, and most importantly white cast iron, malleable cast iron and wrought iron. Now I'm handing over to Hari for the discussion on grey cast iron.
Thank you, Joel. I'm Harinarayanan KS and I'll be talking about grey cast iron. Typically, grey cast iron contain carbon in the range of 2.5 to 3.5 percentage, together with silicon in the range of 1 to 2.8. Other alloying elements like manganese, sulfur, and phosphorus may also be present in grey cast iron. Carbon in grey cast iron exists in free form as graphite flakes embedded in matrix of alpha ferrite or perlite. Moderate cooling from the austenitic range leads to a perlite matrix, while slow cooling results in ferrite matrix. The grey cast iron got the name grey due to the presence of graphite flakes. Grey cast iron is having low strength and brittle in tension, but strength and ductility are much higher under compressive load. Some other properties of grey cast iron are low melting point, good fluidity, good castability, etc. The cost of production is the lowest among the cast iron and hence it is the most widely used type of cast iron. Various uses of cast iron are in automobile parts like cylindrical blocks, cylindrical head, brake drum lining, etc. Thank you, and I will be handing the section to Johan Sabu.
Hari, thank you for the explanation of grey cast iron. Myself Johan. I am here to present ductile cast iron as my topic. When magnesium or cerium is added in small quantities to the grey cast iron, in the molten condition, it leads to a different microstructure on solidification. The carbon exists as graphite, but in the form of nodules or spheroids instead of flakes. This variant of cast iron is called ductile or nodular cast iron. It is also known as spheroidal graphite iron. It is called SG iron for short. Depending on the cooling rate, the surrounding metric space is either perlite or ferrite. A typical combustion would be having 3 to 4.3% carbon, 1 to 3.5% silicon, 0.3 to 0.8% manganese, 0.03% sulfur, and 0.08% phosphorus. The ductile iron is stronger and much ductile than grey iron. In general, it is having mechanical properties comparable with steel. It has superior wear resistance as compared to other cast irons. Typical applications for this ductile cast iron material are for manufacturing parts used in automobile, farm machinery, earth moving machinery, rolling mill equipments, and rolls. It is also used for pumps and compressors, gears, oven doors, valves, valve fittings, and IC engine parts. I am handing over the next part to Jeevan. Thank you.
Myself, Jeevan. Thank you, Johan, for the wonderful explanation about ductile cast iron. I'm going to explain about white cast iron. Cast irons containing lower silicon content upon rapid cooling results in a microstructure in which most of the carbon exists as cementite. The fracture surface of this alloy has a white appearance and thus it is called white cast iron. Composition of a typical white cast iron would be 2 to 3.5% carbon, 0.5 to 1.3% silicon, 0.2 to 0.8% manganese, 0.18% sulfur, and 0.1% phosphorus. Due to the presence of large amount of cementite, white cast iron is very hard and brittle. Also, it is having good wear resistance, high compressive strength, and is difficult to machine. Hence, its usage is also very limited to specific applications. It is used for components requiring high wear and abrasion resistance, pump leaners, and rollers for rolling mills, etc. Used also for the production of malleable cast iron. I am handing over to Heben. Thank you.
Thank you, Jeevan, for your explanation of the topic white cast iron. Myself, Hebin Guriyam, I am here to present the malleable cast iron. First of all, we discuss the production. The malleable cast iron are produced from white iron castings under using a heat treatment process known as malleabilizing. In this process, the white iron is heated above 700 degrees Celsius and held at this temperature for a longer period of time and it is cooled. During this process, cementite in the white iron decomposes into graphitic carbon in the shape of irregular shaped globules. Now, secondly, we are about to discuss its properties. Malleable cast iron possesses good combination of physical, mechanical, and engineering properties. This is mainly because it has having high strength compared to white cast irons, also better vibration, wear resistance, and not brittle as white when compared to white cast irons. Okay, and due to its properties, it has a wide range of applications. And these cast irons are widely used in automobiles, electrical, railway industries, basically due to its good combination of properties such as strength, ductility, wear resistance, machinability. And it is also used for brackets, hubs, brake drums, camshafts, crankshafts, agricultural and earth moving machinery parts. Thank you. Now I am handing over to Joel.
Thank you, Heben, for your wonderful explanation on the topic malleable cast iron. Myself, Joel Kemoni, and now let's discuss the topic wrought iron. So, wrought iron is an iron alloy with a very low carbon content in comparison to steel and impregnated with tiny fibrous inclusions of iron silicate known as slag. The presence of slag changes the chemical properties of the iron, which is enough to create a new and beneficial metal. Wrought iron is a term that is confusing since it refers to both a type of metal and a process of formation. It is having good strength under tensile pressure, resistance to corrosion, and is having malleability. The wrought iron lacks the carbon content necessary for hardening through heat treatment, and also it is no longer produced on a commercial scale. That's it, guys. This is the end of our presentation on the topic classifications of cast iron. Thank you.